This is video number 2 for sections 8.1 and 8.2, simplifying rational functions. When we say simplifying in the context of working with these kind of algebraic fractions, we mean reducing. You're always expected to reduce fractions that you're working with. Now, I got to say here, these kind of problems are just full of places where you can go wrong. You really have to concentrate on the proper approach so that you don't make mistakes all throughout the entire chapter. The key thing to drill into your head is this statement right here, which is the only thing you can ever do to simplify one of these fractions is to divide out common factors of the entire top and bottom. When we use the word cancel, that's what we're talking about, dividing out common factors of the entire top and bottom. Now let me demonstrate this idea with just a simple numerical example, just a regular fraction. Take a look at this problem here. If I were to ask you, can I go ahead and divide out those threes? Hopefully you would say no, of course you cannot do that because these threes are not factors. Factors are the pieces of a giant multiplication problem. These are not giant multiplication problems, these are giant addition problems. That 3 is not a factor, so it would be inappropriate to think about dividing it out or canceling. Well, what if I rewrote this problem like this? All I've done is I've expressed the number 3 as 3 times 1, and I've expressed this number 3 as 3 times 1. Now, would it be appropriate for me to cancel out, divide out those 3's? Well, again, hopefully you realize absolutely not. Maybe it was more tempting this time because of the times. But I mean, look, if I did that, that would just be the same thing we did back here. So clearly, if it was wrong here, it would be equally wrong here. What's the problem with that approach? The problem is this 3 is still not a factor of the entire top, and this 3 is not a factor of the entire bottom. What do I mean by that? The top is not a giant multiplication problem. The top is a giant addition problem. Sure, there's a multiplication in here on the side, but the top is not expressed, nor is the bottom expressed as a giant multiplication problem. These 3's are not factors of the entire top or bottom, and so this approach is completely unhelpful. What would I do with this thing then? Well, I'm sure you realized from the start that what I need to do is I need to add up those pieces. 3 plus 1 is 4. 3 plus 5 is 8. And then, after doing that, maybe I can express the top as a giant multiplication problem, and I can express the bottom as a giant multiplication problem. And now, if I see any factors in common, all 4 of these numbers are factors now, then of course I can divide those numbers out. The final simplified answer to this problem would be 1/2. The only approach that gets you the right answer is to fully factor the top and fully factor the bottom before you think the word cancel. Here's why I'm making such a big deal out of this. I think it's pretty understandable when you're just dealing with regular numbers, but then for some reason, when people get down to problems like this, they just go cancel crazy. And they somehow feel like that anything that looks remotely similar on the top to something on the bottom should just immediately be crossed out. Oh, x squared's 9's, and everybody just starts canceling things out. That's completely incorrect. It's just bad math. It's not true. The only thing you can ever cancel or divide out are factors, which means you have to be looking at giant multiplication problems. You've probably figured out now where this is going. The only way you can simplify something that looks like this is to first factor the entire top and then factor the entire bottom, which means you're going to have to use all those factoring skills back from chapter 6. Just like I did here, I factored the top, I factored the bottom, only then could I reduce. Okay, well, let's go ahead and do that. In this problem, let's see, the top, I'm always looking for a GCF. I don't see one. I have 3 terms. That makes me think this was somebody's FOIL problem. I could Xbox it if I wanted to, but I think this one looks pretty easy. It's got to be X and X at the front. At the back, let's see, 2 numbers that times to 9 and have something to do with a 6. Pretty sure it's got to be 3 and 3. Everybody has pluses. You can double check by foiling, but I think we've got it. The bottom guy, again, no GCF. This one only has 2 terms, and what I notice is it's got a minus in the middle. These 2 guys are perfect squares, so it's one of those difference of square problems, a plus b, a minus b. Now this problem is in the same format as this was back here. I've got a giant multiplication problem on the top. Now, definitely the pieces that I'm multiplying are a lot more complicated than they were here, but nonetheless, I have a giant multiplication problem here. I have a giant multiplication problem here. Now I'm looking for any of these 4 factors that are common top to bottom. And of course, I have an x plus 3 here, and I have an x plus 3 here. Anytime I divide one of those out, well, anything divided by itself is 1. That's why I'm writing the ones. Let me go ahead and put together what we have then. Let's see, 1 times x plus 3 would just be x plus 3, and 1 times x minus 3 would be x minus 3. Well, let's see. Now what do we do? Should we go ahead and cancel now the x's and maybe the 3's? Well, hopefully you're saying, no, stop. That would be bad. That would be incorrect. Because again, those guys are not factors. They are pieces that are being added. Well, there's nothing I can do with those. We're done. This is the final answer. One of the big mistakes people make in these problems is getting the right answer and then messing it up by doing some bad math later. So don't do that. You can only divide out factors. I want to do one more example because this one has a little bit of a different trick to it that I want to make sure you understand. It's just the same kind of problem. When they say simplify in this chapter, they just mean reduce. If your brain is telling you somehow to cross out these x's or these x squareds or these 4's, you need to hold on a second, right? You've got to get used to having your brain call out factor first. Then you can worry about the reducing and the canceling. It's always 2 factoring problems, one on the top and one on the bottom. So let's take a look at these things. On the top, I'm looking for a GCF. I don't see anything. I've got 3 terms. That makes me think this was somebody's FOIL problem. Now this one is a little bit messier than the last one, so I could see where you might want to do an Xbox thing off to the side. If you want to do that, go ahead, do that off to the side and then come back to the video. I think I can just use the trial and error approach, the reverse FOIL. The front of this thing is very easy because my only option is 2x times x to make 2x squared. The back is a little trickier because it could be 2 times 2, although I can't put a 2 here because that would make a GCF. So that makes me think it's got to be the 1 and the 4. Let's see, I just need to decide where to put them. If I want to make a 7 in the middle, I think I better put the 4 here to create an 8, and then the 1 here. As far as the signs, I need a -7, so that would be -8x plus 1x. So there's my factored version of the top. On the bottom, let's see, I do have a GCF. I have an x that I can pull out from both of those guys, leaving me with 4 minus x. Okay, I've now expressed the top and the bottom as giant multiplication problems, right? There is a giant times right here. We don't usually write the dot, but I can if I want to. Now I look for common factors to divide out. Well, I have 4 factors, and this time, at least technically speaking, none of the 4 match. So does that mean I'm finished? Well, not exactly. This one has a little bit of a trick to it. What you might notice is these last two, the last one on the top and the last one on the bottom, they're very close to each other. They're just reversed. So x minus 4, 4 minus x, they're not the same thing because in subtraction the order matters. It still feels like there's something that I ought to be able to do here, and there is. Here's the trick that you use in this situation. One of the two should always look backwards to you. When I glance through these, the 4 minus x, somehow it seems backwards to me. Let me underneath that just write it in what would be the more normal order. I'm not changing anything. I just am going to put the negative x in the front and the positive 4 second. So it's the same thing. I've just written it in a different way. Well, I can take this guy and turn it into this guy up here by simply factoring out a negative 1. Really, what we're saying is, back at the beginning, instead of just factoring out that x, if I had factored out a negative sign along with it, that probably would have been the best. Now, maybe I didn't realize to do that then. That's okay. I can just do it now. Let's write down what the new fraction will look like when we do that. So I've recopied the top. I'm not making a change there. What I'm doing on the bottom is I'm now pulling out a negative 1 from this parentheses. I'm going to join it to that x that I had there before. So now I have a negative and an x on the outside. I could put the 1, I just don't need it. Well, when I pull out that negative sign, what happens here? This used to be negative x, now it's positive x. This used to be positive 4, now it's negative 4. If you were to put that negative back in, you would just get back to what we had, so I know I've done it correctly. Well, see, that factoring trick allows me now to have the ability to cancel out those common factors of x minus 4. So I can divide those out, and what I'm left with becomes my answer. What do I do with that negative sign? Well, it's considered best not to leave a negative on the bottom, and the preferred location for it is just to move it to the side of the fraction. So I would have 2x plus 1 on the top, and I would have x on the bottom, and I have a negative sign in front of my fraction. What should I do to finish this problem off? Should I cancel out these x's? Well, hopefully after this video you're saying, no, of course not, because this x is not a factor of the entire top. This entire top is a giant addition problem, not a giant multiplication problem. I am in fact finished. This is the final simplified answer. Another way we could have dealt with this issue right at the beginning is rewritten that denominator at the start to make it look more normal. We usually put our highest powers first. Now when you do that, you have to make sure you keep all the signs the same. And then when you did your pull out the GCF, you probably would have realized right at the start, oh, I better pull out a negative sign as well. We always pull out negative signs from our front term. And then you would have gotten to this factored format immediately. So you have your choice, but if you don't notice it at the beginning, you can always fix it later on following the method that we used. Make sure you practice this stuff a lot until you get to the point where you are not going cancel crazy. Otherwise, you're going to have troubles throughout the entire chapter.